Hi, Conf. Yeah, so this talk is about how we make money online. And it's about how the web is evolving to make online payments easier, both for us as web developers, but more importantly for our customers. And it's about why I think this is actually important for the web as a whole. Revenue is the lifeblood of companies, and different companies have different methods of making money online. They could have their customers paying indirectly through things like advertising, data mining, or directly through things like e-commerce, taking donations, and subscriptions. Right now, much of the web as we know it is driven by advertising. It's often our first port of call, isn't it? When we put up a website and we start getting traffic to it, we need to start making some revenue to offset those server costs. And the quickest way to do that probably is to add in an ad script. But increasingly, people are questioning whether this has led the web to be balanced more in favor of advertisers than our actual web users. And I'm sure you've all seen plenty of these damaging headlines recently about advertising and ad-based platforms. There's been a lot of attention on whether advertising can be weaponized to spread disinformation and even try to sway voting behavior. Some big brands have been getting nervous, threatening to pull their ads from some of these platforms, and some have even done so. We also have GDPR, the EU's new data privacy regulations, coming into effect in May, and that's been making some companies nervous too. Us as web users have been seeing lots of reasons to be nervous of ads sometimes too. We've had reports of malicious ad scripts even running in UK government websites that are mining cryptocurrency in our browser, or even attempting to hijack data out of our password managers using off-screen input fields. And there's been an increasing recognition, I think, of ads' potential to be invasive, not just of our screen space, as we're all aware, but also of our data usage and even our battery life. Our own tests at Samsung Internet have found that you could get a 19% boost in battery life when browsing just by blocking your ads. So it's not surprising that ad blocker usage is still continuing to rise. Over 600 million desktop and mobile devices last year had an ad blocker installed, according to PageFair. And ad blocking has even been called the largest consumer revolt in history. Now, I need to say that not all ads are bad. Some of them are good, and I've had good experiences where I've actually found out about something that I wanted to find out about. But we do want to protect our users from overly invasive ads and trackers, and we're pro-consumer choice. So our Samsung Internet mobile browser back in 2016 introduced optional content blockers that you can install via these extensions, and an inbuilt tracking blocker in 2017. We've also seen the arrival of dedicated browsers to privacy with tracking blocking enabled by default, like Firefox Focus. And even Google, who are of course reliant on advertising for their core business model, have been moved to introduce their own ad blocking solution. And this works by blocking domains of websites known to violate the Better Ads standards. So if it's possible for us not to be quite so reliant on advertising, that could be very beneficial for many online businesses. So how about asking our customers to pay directly? Well, traditionally that's been hard too. We know from psychology experiments that as soon as we introduce any kind of cost, we'll lose a lot of potential customers. The zero price effect says that even a tiny cost adds this friction. But we know from native mobile apps that in-app purchases have a massive revenue potential, one that now outweighs advertising and the revenue from apps that are paid for up front. And one reason why they've become so popular is because they allow us to try before we buy. We're more willing to pay for 10 alpaca coins after we've spent some time playing with cute alpacas. But this can be problematic too, and there's a responsibility for us as developers to be ethical and not to try to tap into addictive behaviors, especially when it's down to children using these things. But if we're focusing on the user experience, what we can learn from this rise in in-app purchases is that reducing friction is vitally important. Now, Google already have my payment details, so to buy these alpaca coins, all I need to do is tap buy, and then I can confirm my identity. And I can do that easily nowadays with the biometric capabilities of modern smartphones. Nowadays, we don't just have fingerprint sensors, but also iris scanners and Face ID and intelligent scan, which is a combination of those two. But now if we look back at this traditional checkout process that we're used to on the web, the difference is quite stark. I'm sure you've probably all come across checkout flows like this too, where you're faced with pages worth of fields to fill out for your billing, contact, payment, and shipping details. And this is quite likely to make us give up and think, oh, I'll come back to it later, well, maybe when I'm on the desktop back at home, and then you probably never will. And the numbers confirm how big a problem this is. Studies have shown that 68% of shopping carts are abandoned on desktop, and an even more massive 84% on mobile, where the process of typing out all that information on a small touchscreen is that much harder. This costs businesses billions every year in lost revenue. So it's been high time for the web to try to catch up and reduce this friction. Thankfully, that's been the focus of the W3C Web Payments Working Group, which started up a few years ago. Their mission is to make payments easier and more secure on the web. And the first result of that work that we have now is the Payment Request API, which provides an inbuilt browser payment user interface. And the browser support for this is already pretty good. It's been in Chrome and Edge and our Samsung Internet for a little while. I also just recently found out it's in Brave on Android, and it's in Safari Tech Preview on the desktop, and it's coming in Safari in iOS 11.3, which is currently in beta, although Safari is only supporting Apple Pay through this, and it's in development in Firefox. The idea is that you allow the browser to provide the user interface for the checkout process for you. And this can be very useful, especially for new customers where we don't have their payment details yet. But the browser is likely to have those, because if they've used any other website that uses the Payment Request API, and they've accepted the browser's request to save that for future use, then the browser's already likely to have this kind of information, card, delivery, and shipping details. So let the browser auto-populate it for you. But this is better than just standard autofill. Because the browser provides this user interface, it can be totally accurate at filling the right data into the right input fields. And the browser can also do clever things like hook into those biometric sensors on the device. So here's how it looks on Samsung Internet when we click purchase for some socks, of course. It brings up the native payment sheet, and this will be a little bit fast, but we'll see it loop through again. And this payment sheet that is provided by the browser has our details pre-populated there, because that's something I've already stored in the browser, my card details. So all I have to do is tap pay and then type out my 3-digit CVC card from the back of my code from the back of my card and confirm it with my fingerprint. And then I have purchased my pair of odd socks. So how do we use this? Well, first, it's important, as usual, to use progressive enhancement. So we can check if the Payment Request API is supported in this browser, and if so, proceed. Otherwise, we can fall back to our legacy checkout form. Then to use it, first we define the payment methods that we wish to accept. And in this case, we're saying basic card. That's a standard string that identifies the kind of things that you'll find in your wallet, debit and credit cards. You can also restrict it by card network too, like Visa and MasterCard if you want to. And then the payment details, what the user is actually paying for. So here you can define the total and optionally line items as well, and you can define the amount and the currency. Then you pass those two things, the method data and the details, into the payment request constructor, and when you're ready to show that sheet to the user, you call show. This gives you a promise from which you can obtain the response from the user when they've submitted it. And then you can process that data securely server-side and call complete on the response to close the payment sheet with a suitable success indication when it's finished. Now, most often, we won't be processing this sensitive payment data ourselves. We'll be using some kind of third-party payment gateway or e-commerce platform. So in that case, we can use their website, their platform. They might provide us a JavaScript library that we use on our site, or we might use some iframe or redirect solution from them. And they might be the ones to be calling the payment request API for us and take the results securely themselves. So if you already have a payment gateway that you're using, the best way to get started with the payment request is to check with them how they recommend implementing it. But it's good to know what's possible with the underlying API. And it's not just for taking payment details. We can also pass in an optional third parameter to the payment request constructor, which lets us request additional data from the user, like their contact information and their shipping address. Hopefully everything you need to complete your checkout process. And here's an example that shows that, where we've got a bit more information here in the payment sheet. And again, in this case, I've already had this saved in my browser, but I can go through and I can edit that, and I can add new details if I need to. And this is the same interface that I'd use for adding it in the first place if I hadn't added it for any other site as well. And in this case, we have a specific delivery method that we've defined as well. And you can also do things like update those delivery options dynamically based on the address that the customer enters, if you might have different delivery costs for different countries, for example. We can also call can-make-payment if we want to check in advance if the user has a valid payment set up. For example, we might do this for a new customer. So if they already have an appropriate payment method set up in the browser, and we know this from can-make-payment, then we might decide, yeah, let them go ahead and use the payment request for an express checkout option. We could still say, after they've completed that flow, then invite them to create an account on our website. But if they don't have a payment set up already, then we could decide to say, let's funnel them through our usual existing registration and checkout process, because they're going to need to enter those details anyway. Browsers have designed this payment request user interface very much with the mobile user experience in mind, but it's a very similar story on desktop too. The payment sheet is usually displayed in a special pop-up or panel. Here's Chrome Desktop on the left and Edge on the right. And we're starting to hear about the effects that introducing payment request is having for businesses. At Chrome Dev Summit in the autumn of last year, they shared an example from the clothing company J.Crew, who had 50% of their users going through a payment request flow, reducing the checkout times by a massive 75%. But we could go even faster, because millions have their card details saved in mobile payment apps like Samsung Pay, Apple Pay, PayPal, Google Pay. And the payment request API is designed to support these kind of third-party payment apps too. These kind of apps work using tokenization, so they don't send over the raw card data, they use single-time tokens. That has additional security benefits, And it also means that the user doesn't have to type in their CVC code from the back of their card, so it saves another step. We can support those kind of apps by specifying them with their special URL in supported methods. And we can pass any additional data required by that particular payment app in the data property. So for example, with Samsung Pay, which we're now opening up for payment requests starting in the US, we can see that we have the regular payment user interface, but because we've defined Samsung Pay as an additional payment option, we have that as our payment option displayed here. So now when we tap Pay, it fires up a payment sheet automatically from the Samsung Pay app. This already has my card details saved again, and I can confirm this with my fingerprint or iris scan, or a PIN if I don't have one of those sensors. Then, once I've done that, it takes me back very briefly to the payment request UI just to see that processing complete. And then that's it. We're checked out. So it was even faster. We didn't have to type out anything. But how does this work in terms of web standards? Well, it uses a spec called the Payment Method Manifest, which is supported in Chrome and in our latest Samsung Internet Beta. If you take one of those app-specific URLs that you can pass into supported methods, and if you were to request the headers on those, you'd find a link to a payment method manifest. And this is a JSON file that looks a bit like this. It defines a default application for payment, which points to another JSON file. And you can also include supported origins for third parties that we also wish to be able to support our payment method. And that second JSON file that was referenced there identifies our particular app, in this case from the Play Store, with a particular package ID. So this will let us define our own native payment apps that we wish to use on the web too, which is neat, but I think we're mostly web developers here. So you might be thinking, that's good, but what if we could write a web app that acts as a payment handler? And the good news is that that's being worked on too. The Payment Handler API is a bit newer and it's currently behind flags, but it provides the ability for you to listen out for a payment request in the background using a service worker. And once you get that request, if you can handle it, you can open up a window to your web app in order to pay it. So here's a demo running in Chrome with that flag switched on. And once we tap Pay, the first time, it will now spin up our payment web app, which is here. And then on this one, when we tap Pay again, that's it, we've completed payment. So I think we're making big strides on the web to make it easier to take individual payments. But lastly, what about subscriptions? A lot of businesses are reliant on taking regular payments from their customers or supporters. And traditionally, this has been a tough sell for people too. But there has been some good news on this recently too. In the last year or two, many organizations have been seeing an unexpected rise in their paid subscriptions. The Guardian, for example, now makes more money directly from their readers than they do from advertising, with 500,000 paying supporters. And we've also seen the rise of platforms like Patreon, which is for fans to pay creators. For example, caniuse.com, which Harry showed earlier, lets you pay $1 a month using Patreon and disable the ads on the website. Another one to keep an eye on is Brave's payment system, which is based on basic attention tokens, or BAT. The Brave browser blocks ads by default, but you can choose to reward websites with a monthly contribution, and the browser will divide that up between the sites that you visit automatically based on the attention time that you give them. And the next stage they're aiming for is for that to be able to work the other way around too. So you can choose to see ads, and in return get rewarded with tokens back yourself. BAT is a cryptocurrency, and that has a barrier to entry, and I think there are many problems with cryptocurrencies right now, which we'd better not get into today, but I do think this is a very interesting concept. The blogging platform Medium previously had an ad-based revenue model, but they saw that it incentivized clickbait. So last year, they switched to a subscription model. And like BAT, it divides up revenue between the publications that you visit automatically, but they do it not just by reading or attention time, but the number of claps you give those articles. As a user, I don't particularly like having to click a button multiple times or even hold it down, and I find it hard to judge how many claps to give, because how many claps have I given to other articles? Oh, was that one better or worse than this one? I don't know. So that's why I only ever give one clap myself. Apologies to any fellow authors on Medium. But I really like that they're experimenting with this. I hope that the web can learn from it, and I hope that we can experiment with different user experiences and business models too. If we can find a way to have more of our customers pay us directly and be less reliant on things like advertising, perhaps we can focus more on our customers. As a blog post on Medium said, a funny thing happens once you completely focus your business around making paying customers happy, your product gets better. So by taking a fresh look at how we make money online, using some of these latest web features and ideas, and experimenting, perhaps we can help to make the web a better place. Here's the link to the slides, which I'll tweet out as well. Thank you for having me.